continuation of the ones we started on Wednesday. Same idea, we're optimizing. Optimizing is finding the maximum and minimum. Okay, so what you want to do is you want to get an equation for the thing that you're trying to maximize or minimize. You want that equation in one variable. You need to make it into one variable. Take the derivative of that equation, set it equal to 0, bless you, and that will get you your critical points, and then you can test those to see whether you have your maximum or minimum. So the idea behind this one is I have an 8 by 12 piece of cardboard, and I want to make an open top box by folding it up. And I do that by cutting out square corners out of each side, and I want to find my volume. What's my maximum volume by cutting out the equal amounts on each side? So if I have my box and I want to know how much is that length, what is the length of the square that will give me my maximum volume? Well, volume is length times width times height, and I need to do that into one variable. Well, the height is x. When I fold up the sides, it's whatever I cut out, that's the height of my box. So I have x. And then I need to get my length and my width. So this distance here is going to be what? 12 minus 2x. So I get 12 minus 2x. And my length down this side is going to be what? 8 minus 2x. And that's my volume. Okay, that's my formula. Now, in order to help us when we find our solution later, what are my domain restrictions? What is the smallest box, what is the smallest I can cut? It has to be greater than 0. The smallest amount I could be is 0. I can't cut less than 0. And if I cut 0, what's my volume? 0, because I'm not folding up, right? So my domain has to be at least 0. And then what's my maximum I can cut out? It would be 4. Because this side here, looking at this one, 8 minus 2x, if I cut out more than 4, then I've got a negative amount that I've cut. I've cut more than halfway if I cut out more than 4. So 4 is my maximum. My answer has to be between 0 and 4. So if I get other points, that will work. Okay? You want to get your favorite calculator for this. Now, before I take the derivative, you want to multiply that out. So I get 12 times 8 is 96. So I get 96x. And then I have 16 plus 12 times 24, right? 16, yeah. 2 times 8, 2 times 12. 16 plus 24, that's 40, right? Minus 40x squared.
Are we going to graph it out?
Plus, I'm not going to graph it. Don't need to. Plus 4x cubed. Check me. Make sure I foiled it out correctly and then distributed the x. I do believe that's right. Is that right? Okay, so that's the formula for my volume. What I want to do is, now what do? I take the derivative, set it equal to 0. V prime is 96 minus 80x plus 8x squared. 12x squared. Thank you. I have a feeling today I'm going to be a little off on a couple of things. Please check me and watch me on this stuff. I don't know. I just got a feeling for some reason today. Set that equal to 0. And I don't think these come out to be whole numbers, which is why I use my favorite calculator to do the solver.
How do you do the solver on it?
Well, it depends on your calculator that you have. For mine, you can just do the polynomial, which is what I will do the polynomial on this one. Polynomial, degree 2. Type in the first coefficient, 12. The second coefficient, negative 80. And the third coefficient, 96.
I didn't know that was a thing.
And hit solve, and I get 2 answers. I get x equals 5.097 and x equals 1.569. However, one of those is outside my domain. So that's how much I got out each side. Just a little more than 1.5 inches. And that will give me my maximum. You have a couple of problems like this in your homework. Use the pictures and diagrams that are in your book. And I cannot stress enough, draw diagrams to go with your work. Label the diagrams like I did here on this one. Even if it's in your textbook, copy that diagram on your paper. And there's one of them in your book where what you're actually making is a suitcase, which is 2 of those put together. Read it carefully. Read the question carefully. Look at the diagram. Read it carefully. And when you look at the diagram, it's confusing, but if you can picture in your mind, oh, that's 2 of these folded together, it actually makes sense. Okay? So, and notice the directions say, use calculus. Because I know you did this in pre-calc by graphing and using the graph to find it. It's not what I want. I want to see the derivatives being used.
You know,
Yeah.
we're only finding 5.097.
Okay, let me pause for a second. Pick this back up. So any questions on this one? I think it's fairly straightforward. This is a diagram to go with that. Basically, it's the same idea of what we worked out. Okay, I like this one. Okay. You have been asked to design a 1-liter oil can shaped like a right circular cylinder. What dimensions use the least material? Using the least material. Okay. So this is practical. This is a really good practical kind of thing. What I'm trying to do is I'm trying to design something because you want to use the least amount of material possible, because if you're in manufacturing and you're making billions of these, it matters. Okay? It matters how much material you use, because if you use a little bit more than you should or need to, that adds up in a hurry. Think about how many cans Pepsi makes. Okay? There's a reason Pepsi cans don't have stuff on the top and the bottom. Only goes around the outside, because the amount of ink that they use to put on the outside to design the cans will cost more if they put ink on the bottom and ink on the top. Okay? There's a reason for that. There's a reason for their design, because if they use just that much, too much aluminum, it will cost billions of dollars for how many cans they make in a year. So they want to be as efficient as possible. They want to make it using the least amount that they can possibly get away with and still have it be the proper size. And there's a reason why these things are designed and made that way. Okay? And sometimes it's surface area this one's the surface area to volume ratio. The other ones you're looking, okay, all I need is my outside surface area. I'm not so worried about the other things. Different parts cost different things. How much waste is involved when you stamp it out? Now, with like aluminum or metal, you stamp out the top and you stamp out the bottom. All the leftover parts can get melted down and resheeted and used again, right? So there's not a lot of waste when it comes to that. But other times you can't. You got cardboard that where you're cutting these out of cardboards, the tops and bottoms out of cardboard circles. What about all that little stuff that doesn't get cut out? That's waste. And that's harder to recycle than it is for the metal. Things you need to think about when you're doing manufacturing. So, what am I trying to minimize? I'm trying to minimize the least amount of material, which is surface area, because the thickness of the material is essentially uniform. It has a uniform thickness. It doesn't waver. It's not like, ooh, the top is thicker than the bottom, and that kind of stuff. It's a fairly uniform thickness on the material that I'm using. So that means I'm trying to minimize the surface area. Okay. So I have an equation for the surface area, but I have a problem. Too many variables. Area is both the product of radius and height. So I need to eliminate one of the variables. But I have a second equation that talks about volume, because I have a very specific volume that I'm going to do. My volume is 1 liter, which is 1,000 centimeters cubed. So we're doing this in centimeters. So I want to eliminate one variable. I can eliminate R, but if I'm doing R, if I solve this equation for R, that means I'm going to be using square roots. Do you really want to take a derivative with a square root? No. So what do you want to do? You want to solve this for H, and then take that, plug it into the second one. So to solve this one for H, divide by pi r squared, and I get H equals 1,000 over pi r squared. And I take this and plug it in there. Okay, so my area equals 2 pi r squared plus 2 pi r times 1,000 over pi r squared. Simplify. Area equals 2 pi r squared plus 2 times 1,000, 2,000. The pi's cancel. One of my r's cancel over r. Woohoo! And now what do? Take the derivative, set it equal to 0. So A prime is equal to 4 pi r minus 2,000 over r squared.
Why is it minus?
Okay, because, why is it minus? Because if I were to rewrite 2,000 over r as r to the -1 power, bring down the -1, decrease by 1 to get -2, but then you put it back in the denominator in order to be able to make it easy to solve. It's one of those things, when you take the derivative with square roots involved, you change your square root to a fractional exponent, take the derivative, put it back in square root form for solving, because it's much easier to solve in square root form than fractional exponent form. This is easier to work with an exponent in the denominator than it is with a negative exponent. We don't think about solving the negative exponents. So we set this equal to 0, which means that we have 4 pi r equals 2,000 over r squared. Multiply both sides by r squared. Divide both sides by 4 pi. You get r cubed is equal to 2,000 divided by 4 is what? 500? Yeah. Over 500 pi, which means that r equals the cube root of 500 over pi, which is approximately 500 divided by pi equals, I'm going to take, root 5.419, 5.42. R is approximately 5.42 centimeters. And then we can take that, plug that back up into here to find the height. That'll give us our dimensions. Okay. So the key to doing these problems, once again, the most difficult thing, honestly, the most difficult part is getting it in one variable. Getting in one variable answer or one variable equation. That's often why you're given the information. Does the volume matter? Yeah. We didn't tell me what my volume had to be. I couldn't get my area into one variable. That's the most difficult part, is figuring out one variable. What's my one variable? How can I take the equation and do it into one variable? Often you will have to write 2 or 3 equations and simplify one down. And it's the one you want to maximize that needs to be in one variable. Bless you. Okay. That's the most difficult part of this one, mostly. There is the calculus taking the derivative, then there's the algebra solving it, which is not necessarily easy. But coming up with one equation with one variable, that's the part that tends to be the trickiest one. Where do you start? Write down all the information you've got. That's where you start. Draw diagrams. I cannot stress enough to draw pictures and diagrams to go with the word. Okay? So example number 6. You have been asked to design a poster for an upcoming concert. It contains 60 square inches of printing with a 3-inch margin at the top and a 2-inch margin on the sides. What dimensions will maximize the amount of paper used? Or sorry, minimize the amount of paper used. Okay. First, draw a diagram. By the way, the grades I've submitted for the progress report do not include quiz, just because I submitted them before I graded the quiz. And I don't feel like going back and changing. I just don't feel like we're not that it's all that hard, but it's, yeah, it's good. It's only a snapshot in time anyways. Grades are fluid. Okay, so your first thing, like I said, is you draw a diagram. I have a poster. X, Y, 60 square inches for that portion. And then I have a margin across the top and a margin down the sides. 3 inches, 3 inches, 2 inches, and 2 inches. What I wish to do is to minimize the area of the whole thing. Does that make sense? So what I want to do is I want to minimize this times that. Okay, the length across the bottom, if that's x, the length across the bottom would be x plus 4, right? Because I got x for here, and then 2 inches on each side. The dimensions for the length or for the height would be y plus 6, because I've got this. So the area I want to minimize is x plus 4 times times y plus 6. How many variables do I have in there? 2. Oh, poop. That's one too many. So that means I need to somehow use the other information to come up with a single variable. My other information that was given to me was the poster section, the printed section here in the middle, is 60 square inches, which means that x times y is 60. Solve for x, solve for y, it doesn't really matter in the long run to get the same dimensions. If I divide both sides by x, I get y equals 60 over x. Which means that my equation for the area is x plus 4 times 60 over x plus 6. It would really suck to take the derivative of the area and set it equal to 0 as it stands. Multiply it out. Four times 60 is 4 times 6 is 4. I know some of you are OCD and want to combine up the constants, but I'm taking the derivative. I don't care. So if I take the derivative, a prime, the derivative of 60 is 0. So I get 6 minus 240 over x squared. The derivative of 24 is 0. So that's why I don't care about combining 60 and 24 into one term, because the derivative of each of them individually is 0, as would adding them together would give me 0. And what do I want to do here? Set that equal to 0. So that means 6 equals 240 over x squared. Cross multiply. See, here's a nice thing. Okay, 6 is 6 over 1, right? When you have two rationals equal to each other, one of the things you do is swap the means and extremes. That means I can just swap the x squared and the 6, and it's still equal to each other. So I get x squared equals 240 over 6. So 240 over 6, that's 40. X squared equals 40. X equals the square root of 40. which is 2 root 10, which is, take the thing on your calculator to get the decimal approximation. 6.32. Approximately 6.32. And then you can take this to find the y dimensions, because what is y? Y is equal to 60 over 6.32. Which would be approximately 9.49. We have our dimensions. And we can find the dimensions of the poster by adding 2 to one side and 6 to the other length, and we've got what we want. Okay? Draw the diagrams, though. The diagrams are the secrets of this whole thing. Draw your pictures. Draw your diagrams. Questions on this one? Okay, so this one's a little different, but it fits in with what we're doing. This is a straight up AP question as well. What values of A and B have a local minimum at x equals 2 and a point of inflection at x equals -1? How do we find maximums and minimums? Where the derivative is equal to 0. How do we find points of inflections? Where the second derivative is equal to 0. So what I want to know is f prime of 0 equal to f prime of x, or actually it should be f prime of 2. F prime of 2 equal to 0. And f double prime of -1 equal to 0. What values of A and B give me that? That's what that question is asking me. So my first thing I'm going to need to do is find the first and second derivative. So the derivative of f of x, f prime would be, f prime of x, would be 3x squared plus 2ax plus b. F double prime of x would be 6x plus 2a. How many variables am I looking for? I'm looking for 2 variables. I'm looking for A and B. X is technically not a variable for my solution, but I'm looking for A and B. I'm looking for 2 things. Here's the secret. If I have 2 things I'm looking for, I need to have 2 equations. I need to have 2 equations to find those 2 things. So when I say that f prime of 2 is equal to 0, that means when I plug 2 in for x, it's equal to 0. So I put 2 in for x, that gives me 4 times 3, so I have 12. Put in 2 here, plus 4a plus b is equal to 0. I put -1 in for x here, -6 plus 2a is equal to 0. F prime of 2 is equal to 0, f prime of -1 is equal to 0. Solve 1 for a, take that, plug it in the other one, and figure out what b is.
Let's go.
So a would be 3, correct? Yeah. Add 6, divide by 2, a is 3. Plug in 3 here. 12 plus 12 plus b is equal to 0. B would be -24. This one is all about, do you understand how to find your minimums? Do you understand how to find your points of inflection? That's what this question is all about. That's what this question is testing. Do you know how to find a minimum value? Do you know how to find a point of inflection? That's it. That's what this is. I've seen this on an AP practice test. I've seen this on released AP tests. Right? It's part of the reason why I started throwing it in on the homework and on the notes. But that's what this is about. Do you understand the concept? This is not a question about calculus. Well, this is a question about calculus. This is not a question about calculating. This is a question about concepts. Do you understand the concept of finding the minimum? Do you understand the concept of finding the point of inflection? That's what this question is designed for. The actual finding the numbers is just a process of showing me that you understand that. That's what the question's about. Okay? Anything else? Awesome.